All right, welcome back to pre-calculus. This is going to be problem number 2. I believe we are looking at trying to graph the polar function 1 plus 4 sine theta. We've got to make a Cartesian type of a graph. We've got to sketch it in polar coordinates, and we have to figure out at what angle the graph touches the origin. Please use degrees for these answers. All right, first thing to do, let's go ahead and withdraw a Cartesian coordinate system. Um, we're going to go ahead and do this. So we've got, here's my theta, here's my r. So this is a Cartesian coordinate system. I'm going to go 1 unit up because that one says go 1 unit up. Okay, and we'll draw a little axis in here. 1, 2, 3, 4, 5. And then we have 1, 2, 3, 4 down there. All right, we're going to go ahead and generate our points. We've got 2 or sorry, pi over 2, and then 3 pi over 2. Okay, so we're going to go ahead and do our little dance of the signs. So we have a 0. It's going to be up here. Okay, at pi, we're going to go back to sine of pi is 0. So we're going to be back down to here. Sine of 3 pi over 2 is going to be -1. So we have 1 minus 4, which is going to be -3. Okay, and then back up to sine of 2 theta. So that's going to be sine of 0 or sine of 2 thetas, which is 0. 1 plus 0 is going to be back to 1. All right, so we'll go ahead and we'll sketch in our graph here. Okay, hopefully better than this. It doesn't really look like this, but there we go. All right, so there we have that. The next thing we're going to do is we have to go ahead and draw this in polar coordinates. I handed you guys a polar coordinate graph paper. If you don't want to use it, that's fine. So we'll go ahead and figure out what's going on with this. All right. So at the angle of 0 degrees, we're going to be r is equal to 1 unit away. Okay. As we sweep up to pi over 2, we're going to be 5 units away. So 1, 2, 3, 4, 5. Okay. So we're going to be sweeping up to 5. Okay. So we're going to get 1 all the way up to 5 here. All right. Now, keep going. We're going to go from pi over 2 to pi. And then from pi over 2 down to pi, we're looking at the pi degrees, right, or pi angle. We're looking over here, okay? And then we're going to say that we are going back down to just the 1, okay? So we're going to be 1 all the way up to here, okay? Now, between pi and 3 pi over 2, we are actually going to cross over and hit the underside of this thing, okay? So we're going to go ahead and figure out what's going on with this. So right here, somewhere in here, we're going to go get our underside of this, okay? Now, at 3 pi over 2, so I'm looking straight down like this, okay, straight down, but we are -3 units away straight down. So it's going to be 1, 2, 3 backwards. We're going to be up here at 3 units away. And then I'm just going to fill in the rest of this piece and then kind of come out like that. Okay, that's a terrible graph, but that's kind of what we're looking for to show what a lemicon this is, a lemicon with an internal loop, and that's what's going on. Other things that they asked me to do. So that's my polar coordinate graph here, such that it is. The other thing they asked is where does the graph actually touch the origin? So we're going to go ahead and calculate that. So we're going to say 1 plus 4 sine theta is equal to 0. Okay, we're going to solve this. So we're going to say, okay, well, this is 4 sine theta is equal to -1. Subtract 1 from both sides. So sine of theta is equal to -1 over 4. Okay, now what I have to do is go ahead and do what the inverse of this is. So we have theta is equal to the inverse sine of -1 over 4. Okay, here's where it's going to get a little tricky because I think I'm in degrees. Okay, let's go ahead and clear everything here. So we're going to say this is the inverse sine of -0.25. Actually, I'm going to do 0.5 for a moment just first. I'm going to just say just 0.25 because I'm going to get the reference angle for myself first, and then we'll go ahead and show you what has to happen with everything else. And that was 14 degrees. So my theta reference Okay, and that was going to be, here's our 14.48 degrees. Okay, so that's my reference angle. That is not exactly where I want to go yet, but that's my reference angle. So look here. We are going, we want we want 14.48 degrees. Now this is going to happen in quadrant 3 and quadrant 4. Okay, so I want quadrant 3 and I want quadrant 4 where this is actually happening. So we're going to say 360 minus my 14.48 degrees, and I get that as an angle. Okay, so we're going to say that we want 360 minus 14.48 degrees. So one of my angles is going to be 345 degrees. 345.52 degrees, 345.52 degrees. One of my angles is going to be 14 degrees below the horizontal in the third quadrant. So my theta 1 is going to be 180 plus 14.48 degrees. Okay, so that's going to give me 194.48 degrees. And these are the two angles where the polar coordinate graph hits the origin value. Okay, that would specifically be here and here on my Cartesian graph. Okay, but that's where that would end up at. Okay, and I think that's what they asked us to go ahead and solve. Yep. Well, we could figure out where does it touch. We made a sketch. I think we're all set. We have our main graph here. Everything is done, and that's kind of what we're looking to do. All right. So for that, I will say thank you very much for watching the video. Good luck studying, and we will see you in the next video.